Welcome to Mr. Sweeney's AP Physics C class. Today we're going to be talking about uniform circular motion, which is section 4.10 in our forces note. And uniform circular motion refers to an object that's moving in a circle with a constant speed. Speed does not depend on direction and is therefore constant. Velocity does depend on direction and is therefore changing. So this means all objects that are turning are accelerating. Centripetal acceleration. Centripetal acceleration is the acceleration directed at the center of circular motion. So objects moving around in a circular pattern accelerate with their acceleration pointed at the very center of the circle. The velocity that the object is undergoing acts at tangent to the circle at any point. So wherever the object is in its circular motion, the velocity at that moment is directed tangent to the curve it is taking. Our equation for centripetal acceleration is acceleration centripetal equals velocity squared divided by radius. And this is the velocity at tangent, and this is the radius of the circle that it's making. You'll see on the diagram to the right, I've labeled both the velocity and the acceleration vectors. The velocity vector is acting tangent to the circle at that point, and the acceleration vector is acting at that point but pointing towards the center of the circle. As far as our variables, a sub c is our centripetal acceleration, velocity is our tangential velocity, and r is the radius of the circle. So let's try an example of this. Here we have a 0.5 kilogram object moves in a horizontal circular path with a radius of 0.25 meters at a constant speed of 4.0 meters per second. What is the magnitude of this object's acceleration? So our variables, we have mass equal to 0.5 kilograms, we have radius is equal to 0.25 meters, and we have velocity equal to 4 meters per second. Taking these three concepts, we can identify the relationship centripetal acceleration equals velocity squared divided by radius. Plugging into that, we find that centripetal acceleration equals 4.0 meters per second squared, or meters per second squared, divided by 0.25 meters, and that gives us a centripetal acceleration of 64 meters per second squared. Centripetal force. Centripetal force is the force that is required to keep an object in uniform circular motion. If we are accelerating towards the center of our circle, that acceleration has to be parallel to the force applied on the object. So there has to be some center-seeking force that's pushing this object towards the center, constantly keeping it in uniform circular motion. So this always points to the center of the circle. And centripetal force is in the units of newtons. And we have some equations for this. Force centripetal equals mass times acceleration centripetal. And we use this in conjunction with the equation acceleration centripetal equals velocity squared divided by radius. So to find the centripetal force of something, all you need is the mass, the velocity, and the radius. You'll see on the right, I have another diagram. Here we have velocity still acting at tangent to our circle, but our centripetal force, just like our acceleration centripetal, are pointing to the center of the circle. And we have some variables here that we can identify what they mean. F sub c is centripetal force, A sub c is centripetal acceleration, velocity, v is tangential velocity, and r is the radius of the circle, and m is the mass of the object. So let's try a problem with this. A 1,000-kilogram car travels at a constant speed of 20 meters per second around a horizontal circular track. The diameter of the track is 100 meters. What is the magnitude of the car's centripetal acceleration and centripetal force? We have the following values given to us in the problem. Mass is 1,000 kilograms. Velocity is 20 meters per second. Radius is 50 meters. And we ultimately want to figure out the centripetal force. Prior to finding the centripetal force, we do have to take an intermediate step of finding the centripetal acceleration. That is, acceleration equals velocity squared divided by radius. And that acceleration is equal to 20 meters per second squared divided by 50. And we have a centripetal acceleration of 8 meters per second squared. Moving on to our centripetal force, that is force centripetal equals mass times acceleration centripetal. That is 8,000 kilograms multiplied by 8 meters per second squared. And that gives us a centripetal force of 8,000 newtons. And this is it for centripetal force. The next video will be